My name is Ravi Shankar. I'm a professor in the Computer Science and Engineering Department. I'm also the director of a center called Center for Systems Integration. Right now you are in that lab. This is a multidisciplinary center that welcomes faculty members from all different departments in the College of Engineering. At present we have folks from electrical engineering, computer science and computer engineering working together here. We have been working on a project that has been funded by Motorola for the past 6 years by Mr. Jaime Boras here. He was a senior VP at Motorola at that time. This project he funded us at about $1.1 million over the 6 years, and it has involved over 10 faculty members and 10 graduate and undergraduate students every year. He started out with the vision, designing a cell phone. At present, Motorola takes about 18 to 20 months to develop this cell phone. What Mr. Jaime Boras would like to see happen, what Motorola would like to see happen is develop this product in 1 day. That's the vision, 1 day. That's a tremendous increase in productivity. What we have done over the past 6 years by interacting with Motorola, come up with a methodology that Motorola admits that it can bring it down to about 4 months. We think we can bring it down to 1 month. So we have a lot more work to do, but it's significantly better than the 18-month cycle that we started out with long ago. What you will see going around, if you look at the posters here, we have several posters here. And each of those posters represents the work of 1 or 2 faculty members and 2 or 3 graduate and undergraduate students. Many of these projects actually involve cross-disciplinary efforts because the challenges are at the interfaces of all these.
Hello, my name is Agarwal. I'm assistant professor with the Department of Computer Science and Engineering. My main research focus is on performance evaluation, looking at various architectures, multi-core architectures, and specifically network on chip. We have been working very closely with Motorola on resolving many issues and addressing many concerns such as concurrency concerns. I did my dissertation under the guidance of Dr. Ravi Shankar, and that involved a lot of work related to OPP project that we were talking about. Now I also serve as the assistant director to this center. It's a pleasure to be associated with the center. Thank you.
I'm Yunus Karde. I'm assistant professor at this department, Computer Science and Engineering department. I've been involved in the center for the last 3 years. I worked on the OPP project funded by Motorola. The main purpose of this project was to come up with a very drastic improvement in productivity for application design for mobile phones. My research in particular was concerned with requirements-driven design automation. This means helping requirement experts specify requirements and then validating requirements and then automating parts of the design process such that system design can be produced much faster and more accurate.
Okay, good morning. My name is Jaime Boras. I'm currently with Wireless Silicon Group. I'm an ex-Motorola. I just want to give you my view on the project that FAU has done together with us. By the way, I'm also an ex-graduate from FAU, so from 1974, so I've been around for a while. The One Pass to Production project that was done under the Motorola, and I'm very pleased with all of the work that the students as well as the professors have done. They've really engaged with us very closely to understand our needs and then to be able to put together a methodology, a way to do our needs much faster. And that's really what this room exhibits.
Hey. This is Mr. Wexler, CEO of
Vivaca and Vivaja.
Okay, both
we
of them.
use both languages.
As you can see, we have many industry chief executives come here. Mr. Wexler and Dr. Agarwal are, want to work on a project, network on chip, which is a new way of providing capability on a single chip.
This poster right here belongs to network on chip design. It's a extension of multiprocessing architecture. In multiprocessing normal architecture, they were limited to like how many processors we can put it on per. So a new architecture was developed, and this was called the NOC architecture. Still in research and moving forward towards implementation stage, and specifically many big vendors like Intel have now started working on looking at this architecture, and they are focusing on developing products based on that. So the idea is here to expand the capacity for a chip to incorporate hundreds of processors on that. All these are the processors. They are connected in a mesh kind of fashion. What is happening is each processor here is able to communicate to the neighboring processors. In the conventional architecture, we had many processors, and if we wanted to embed this kind of capability, the performance would have degraded. Not in this architecture. It is
It's a non-blocking.
It's a non-blocking type of architecture. Yes.
Thank you very much.
Thank you very much. Thank you.
Hi, hello everyone. My name is Mirela Fonoge,
And I am Mihai Fonoge.
and we are both PhD candidates. We are going to give you some high-level overview about the technologies and applications that we've been involved with.
Since working in the CSI lab.
The first technology we are going to speak about is the Microsoft Robotics Studio, which is an environment for building robotics applications. Build your own components and describe the relationships between the environment and the components and between the components themselves. We have a visual language, we have a 3D simulation, and it has an easy access to the sensors, robots, sensors, and actuators. Here we have some applications that can be designed in Robotics Studio. It's amazing what you can do with this.
Another technology that we have been involved with is Google Android, which offers you a complete and modern embedded operating system. But the best part is the fact that it's an open platform, which means it's open for everybody who wants to use it, starting with developers, users, and going through the industrials. There's also a freedom to integrate with any technology that you want. Basically, what Google Android means is that they give you the client platform. What you do on the server side, that's up to you. We have participated in the Google Android Developer Challenge with our own application, which is called AndroMed, location-based medical system. What you can do, you can search and display information related to any medical term or drug. Yes. SysML and UML, which basically stands for System Modeling Language and Unified Modeling Language. These are graphical modeling languages that are used to model the systems. Why do we actually need to model the system first? And I think the best answer is that because it makes you think about the system. Basically, to come up with the set of components that build your system, and also specify how those components interact. And these are just a few diagrams that are available and which we have used in our location-based application.
Related with UML, we have looked into Executable UML, which is XUML. You can design your system in using XUML, execute that model to find errors, and then you can even generate executable code. By finding errors at an early stage of the system development can save money.
The last project that we want to talk about is a framework that we have built for a requirements-driven system design automation. A process of choosing the right components to build our system. By working in the CSI lab, it gave us a chance to come in contact with a diverse set of technologies and work on multiple projects, and basically enhance our engineering experience here at FAU.